What's up, guys? It's Mr. Brengle, and today we're going to be going over the series circuit V equals IR calculations concept builder. I'm probably going to have to break this one down into two videos. I'm actually going to go through the master level in this video and then the wizard level in a separate video. The apprentice level is pretty simple, so by talking about the concepts in the master and wizard level, you should be able to do that one. So let's go ahead and start with our master level here, and let's kind of look at what's going on. We've got a battery here, and it tells us the battery voltage in this first column. Each row is its own problem. So you're going to be looking at row A and filling this out, and then move on to row B and so on and so forth. So battery voltage is in the first column. It then tells us the first and second resistors here and here. And then REQ stands for equivalent resistance. It is the total resistance of the circuit. And that's always going to be calculated by adding resistor 1 and resistor 2 together in a series circuit, or adding all of the individual resistors together. So for this particular instance, we have two 4.5 resistors, which add up to a total of 9 ohms of resistance. And then it's asking us for the current at point A, point B, and point C. Well, with a series circuit, the rule is that the current is the same everywhere in the circuit. I like to think about it as a single lane highway because there's only one pathway here. And maybe you can think of the total resistance as a semi-truck that's out in front of all the cars, and the cars are the electrons. And if there's a semi-truck out in front of a bunch of cars in a single lane highway, you can't get around the semi-truck. No one can go faster than the semi-truck. The semi-truck is leading everyone at a slow pace and moving around in that loop, and the electrons cannot move any faster. It's just a constant speed behind that semi-truck. So the current is the same everywhere because that total resistance is what acts on the electrons. And it's not like they slow down, they're going fast and slow down when they hit R1 and then speed up and then slow down when they hit R2. It's not like that. They just move at a constant speed because that total resistance is acting on the electrons at all times. So to calculate the total resistance or the total current is calculated. Current is equal to voltage divided by resistance. So if we're looking for the total, then we're simply going to take the battery voltage divided by the total resistance. So 18 divided by 9 in this case is going to give us a current of 2 amps everywhere in the circuit. And so we can go ahead and fill that in. Our second problem is very similar. We need to solve for the total resistance first, which is going to be adding resistor 1 and resistor 2 together. So 3 plus 6 is 9. So we have the same resistance in this circuit. And the same battery voltage. So when we do our calculation down here to get the current, we're going to take the battery voltage, which is 18 volts, and then you're going to divide that by the total resistance, which is 9, and we're going to get a current of 2 amps, and that will be the current everywhere in the circuit. On our next one, we are actually given the total resistance here, the equivalent resistance, and because we know the first resistor is 2, that means that this second resistor must be 4 ohms, or must have 4 ohms of resistance, so that these two add up to 6. And then we're doing our same calculation here. We're going to do, to get current, we're going to take battery voltage of 18 and divide that by total resistance of 6. That is going to give us a current throughout the entire circuit of 3 amps. And on our next one here, it looks like what we need to do is actually solve for the total resistance a different way. Now, notice that it has told us here that the current at point C is 1.5. Well, since the current's the same everywhere in a series circuit, we know that the current at A and B must also be 1.5. Now, to solve for total resistance here, we can do it a different way than what we did before because we obviously don't have this resistor here. So if I'm writing out another equation here, the other version of this, resistance is equal to voltage divided by current. So if we take the battery voltage of 18 and we divide it by the current of 1.5, we'll get 12 total ohms of resistance here. So I need to put this in. Okay, so all I did there was 18 volts divided by 1.5 amps to get 12. Well, if our second resistor is 4 ohms, and that means this first resistor here must be 8 ohms to match up. Now, as you go along, if you're not sure that you've done something correctly or you want to check your work, you can always check this, click this button here, check answers. And this is going to tell us if we've gotten things correct. So if it marks it in green, you've gotten it correct. Now I'm just going to fill in a random number here. And so if we check the answer and to get it wrong, it's going to be red. Now, that's not going to make you start over or anything like that, but you do have a health bar that you cannot see at the moment. And if you get too many of these wrong, your health will go down to 0, and then you'll have to restart. So definitely want to be careful with that. Okay, now on this one here, I'm going to go ahead and get rid of this since we know that's wrong. Since it's given us the current at point A, we know that the current at point B and C will be identical, so we can go ahead and plug in 1.5 here. Okay, and then we're going to solve for the total resistance the same way using this equation down here. We're going to take our battery voltage of 24 volts. We're going to divide that by the current of 1.5 amps. And that's going to give us 16 ohms of total resistance in this circuit. Since we already have 12 ohms in the first resistor, that means the second resistor must be 4 ohms to add up to 16 there. Now in this last one, it has given us one of the resistors and the total, so subtract them and you will find that the first resistor is 4 ohms. Then we can solve for the current the same way that we did in the first couple examples. Current will be battery voltage of 6 volts divided by the total resistance of 12 ohms. That is going to give us a total of 0.5 amps of current in this circuit, and that will be everywhere in the circuit. Okay, we'll go ahead and check our answers, and we've completed the table here. So right there is the master level of your series circuit calculations, and I'll have a separate video for the wizard level here. Make sure to let me know if you have any questions.